Dear students, in this video section, you are going to learn the 8th standard chemistry. The 8th standard chemistry, the topic name is chemistry in everyday life. In our daily life, what are the different ways the chemistry helps us, and where and all we are using the chemistry. In each and every activities, we are using the chemical substance. Without the substances, especially without the chemical substance, our life will not be succeed. This is the thing should keep in your mind. So in this lesson for your 8th standard, this lesson is given. What are the subtopics are given in this lesson? Petroleum and fuel. Before this petroleum and fuel, there are some topics are given. That is hydrocarbon and coal. That one of our teacher will teach. So last topic of this lesson is petroleum and fuels that I am going to teach now. So first we are going to see petroleum. The petroleum, the word is derived from Latin words. There are two Latin words are used to derive the word petroleum. One is called petro, one is called petro. The meaning of petro is rock. The meaning of petro, rock. The other word is called oleum. What is another word is called oleum. The meaning of oleum is oil. So that is rock oil is otherwise called petroleum. What is rock oil? So there are the two Latin words are there. One is called petro, another one is called oleum. So meaning of petro is rock and oleum is oil. So this is called the petroleum, the word derived. So petroleum is a complex mixture of hydrocarbon. What is it? Is the complex mixture of hydrocarbon. It is in the form of, actually the petroleum in the form of liquid, gas and solid. Liquid, gas and solid. Actually this is present in earth. This is present in earth in the form of liquid, gas and solid. Petroleum is not directly obtained. We are drilled from the earth. This is obtained by a crude oil. This is not obtained directly as a petrol. This is obtained as a crude oil. This is a mixture of petroleum product. It is a mixture of petroleum product, crude oil. So we are drilled from the earth by using of we are drilling in the earth. There is a well in the earth. We are taken out the crude oil from the earth. Just we are taken out the crude oil from the earth. After taking the crude oil from the earth, actually very deep from our earth, just it is pumped out. Crude oil is pumped out, and it can be separated out a different petroleum product by using of what is the refining process. By using of the refining process, it's not directly getting us petrol or petroleum product. This is given us, or this is we are getting us crude oil. Crude oil is separated by using of the different process that you will see later. This is about petroleum production. Next we go occurrence of petroleum. Where and how this petroleum is obtained. We are getting the petroleum occurrence, sources of petroleum. Generally, petroleum product is obtained where? Yeah, in foreign countries. Mostly it is obtained from the foreign countries like USA, Kuwait, Iran, Iraq, and the South Arabian countries. South Arabian countries, Iran, Iraq, Kuwait, and USA. Mostly petroleum producers are, petroleum producing countries are. These are all called producing countries. USA, Iran, Iraq, and Kuwait, etc. So in Asian countries, especially in India, some of the places just we are producing petroleum product. Where now? Gujarat, Maharashtra, Gujarat, Maharashtra. Even in Andhra Pradesh, Godavari and Krishna Basin. Where? In Andhra Pradesh, Godavari and Krishna Basin. Even in our state, in Tamil Nadu, Kaveri basins, we are producing petroleum. But this, in even India, some places we are producing petroleum, no, that will not be satisfied our need, satisfied our fulfillment. It does not be fulfilled. So that just we are what is importing the petroleum. Understood? So here, then it's drilled out, it's taken out. Crude oil, that crude oil is going to separate out, that means separated a different petroleum product by using a process. That process is called a refining process. Next we are going to see refining of petroleum. Refining of petroleum refining. The process of separating different petroleum product. Actually different petroleum product from the crude oil. Even the crude oil contains some what is mixture, that means some unusual things, unusual product. From the unusual product, from the unusual waste product, we are separating petrol and different kinds of petroleum product. That process is called refining. What is separating of petroleum product from the crude oil? That while separating, we are removing the waste material. That should be keep in mind. It is the process of separating petroleum product from crude oil. So this process is called refining. The refining process contains some steps to separating the petroleum product. First one is removal of water. This is the first step. Second step is removal of sulfur compounds. What is second one? The removal of sulfur compounds, sulfur compounds. Then third one is fractional distillation. This is important. Fractional distillation. These are the three major steps involving to refine the petroleum. What are they? Removal of water, removal of sulfur and its compounds, especially removal of sulfur compounds, then fractional distillation. So these are the three steps involving. Let's see one by one in very detail. First one is removal of water. While drilling petroleum, that is while drilling crude oil from the earth, the deep of the earth, there some water also present that is mixed with the crude oil, that should be removed. So that is the first step. What is? We should remove the water from the crude oil. That's why this step is first step, removal of water. Because when we are drilled out from the earth, the mixture of water is present already there. So that also combined, that also collectively comes out. Collectively mixed with the crude oil. So after drilling out Just it should be what? We should separate crude oil from the water. So that this is the first step, removal of water. Okay. So the second one, removal of sulfur compound. Even some of the sulfur compound also present in the crude oil, like sulfur dioxide, sulfur trioxide. Such a compound should be removed. So this is the second step, the removal of sulfur compounds. The third, fraction distillation. After removal of this wastage, now it is crude oil. The few crude oil is there, that should be distillated. So this is actually the fraction distillation. Actually the crude oil is heated about 400 degrees Celsius. It is heated about 400 degrees Celsius. Actually this is the process. This process is heated. First is heated, then it cooled at the different boiling point. While cooling in the different boiling point, we can get the different petroleum product or the different boiling. Understood? First we should heat the crude oil above the 400 degrees Celsius. While cooling, it has a different boiling point. We can get the different petroleum product from different. This is a process, cooling process. That's what this is called distillation. We should be heat, then we should be cool. While cooling, we are getting the, according to the boiling point, we are getting the different product, different petroleum product like fuel oil, gas, that is petroleum gas, this LPG gas, petroleum gas, then petrol, diesel, kerosene, and the naphthalene. This and all just we are getting while cooling. This all the product has different boiling point. For the different boiling point, just we are separating the different petroleum product. Let's see that in very detail. Let's see the different petroleum product obtained through fraction distillation. By the fraction distillation, different petroleum product petroleum. So here we should heat the crude oil up to more than 400 degrees Celsius. After heating by cooling at a different boiling point, we are obtaining this petroleum product. So less than 40 degrees Celsius, what is the gas we are obtaining? Yeah, petroleum gas. This is used as a bottled gas or this liquefied petroleum gas that we know LPG. Then the boiling point of 40 degrees Celsius to 205 degrees Celsius, 40 to 205, we are obtaining petrol that we know it is used as a fuel. Then 660 degrees Celsius to 100 degrees Celsius, between these range boiling point, we are obtaining naphtha. This is used as a chemicals to make a different kinds of chemical. The naphtha is used. Next boiling point of 175 degrees Celsius to 325 degrees Celsius, we are obtaining the product is called kerosene. What is kerosene the product? The kerosene that we know it is used as a jet fuel. Then the boiling point of 250 degrees Celsius to 350 degrees Celsius. Between these range, what is the product is obtained? Yeah, diesel, that we know diesel used as a fuel. Next is 300 degrees Celsius to 370 degrees Celsius, that we know we are obtaining the product is lubricating oil. This oil used as a waxes. Then next boiling point 370 degrees Celsius to 600 degrees Celsius. What is 370 to 600 degrees Celsius? This is used as a fuel oil. The product is called fuel oil. This is used fuel for ships. Next, above, that is more than 600 degrees Celsius, the product is called residue. The product obtained is called residue. This is used as bitumen for road and roofing bitumen, and even for the making roads. That's we are using bitumen. No, that it is the product namely called residue. These are all the different petroleum product is obtained for the different boiling point. Yes. Next topic, we are going to learn fuels. What is fuels? So this topic we are going to see a definition of fuel and types of fuels and the characteristics of good fuel. Then what are alternating fuel? That and all we are going to see now. So first definition of fuel. Any substance, whatever the substance, may be solid fuel or solid gas or liquid, any substances that produces while ignited, that produces heat and what is light energy, heat as well as light energy. That substance is called fuel. Any substances that burns to produce heat and light are called fuels. Fuels, heat and light. Heat and light are called fuels. Let's see types of fuels. What is different types of fuels? Types of fuels. Fuels are different types that you know. The form of solid and liquid and third one is gas. These are all called three different types of fuels. But you know the solid fuels are cow dung, this cow dung and coal and wood. These are all used as solid fuels. Coal, different kinds of coal product and wood and cow dung. These are all called solid fuels. Solid fuels. Then what are liquid fuels that we know? The petroleum product, petroleum oil or fuel oil or petrol, diesel, all petroleum product, petrol, diesel, kerosene, etc. That all comes under liquid fuel. Comes under liquid fuel. Gas, it is petroleum gas, that is LPG, petroleum gas. Petroleum gas. Then there is hydrogen. Hydrogen gas is used as fuel. Even CNG, that is CNG, compressed natural gas, CNG, natural gas, compressed natural gas, etc. These are all comes under. It is gas type of fuels. What are petroleum gas, hydrogen, and CNG? This all comes under gas. So this is three are called types of fuels. What are they? Solid fuels, liquid fuels, and gaseous fuels. Let's see the next topic is characteristics of fuels. Characteristics of good fuel. Characteristics of good fuel. What are the characteristics of good fuel? So the good fuels, which fuel is called as good fuel? So we should have some quality for that. The fuel should be readily available. That is very important. What is first characteristic? That should be readily available. That means it is transportable, easily transportable, and cheap. That fuel should be very cheap. That is economically cheap. Economically cheap. That fuel has what is low ignition temperature. This should be important. The fuel that has low ignition temperature. The fuel which should be good, that has high calorific value. Ignition temperature means the fuel or the substance. By suppose we are ignited, the temperature is called ignition. The low or minimum temperature which the fuel starts burning, that temperature is called ignition temperature. How the fuel should be act as good fuel? No, that ignition temperature should be low, and also the calorific value, which produce more heat energy. That is called calorific value. High calorific value. The fuel should have high calorific value. Then the fuel, when we burn the fuel, that produces less desirable, that means less undesirable product, less residue. Is nothing less residue. The wastage should be very minimum. That's important. The wastage should be minimum, very minimum. So these are all the characteristics of good fuel. Less expensive, it is transportable, easily available, and low ignition temperature, high calorific that should not gives no residue. So these should be if the fuel which is satisfy the characteristics what I have explained these characteristics, that fuel should be is called good fuel. That should be is called a good fuel. Okay. Next we go efficiency of the fuel. Efficiency of fuel. How we can be calculate given the fuel has good efficiency? For that some certain values are there. So that it is called what are known as specific energy. Joule per kilogram. Specific energy. Next calorific value. Next one is octane number. The last one is called cetane number. What is cetane number? These are the what it is to be efficiency. We can be controlled. We can be give that fuel has good efficiency. For that, these conditions should be fulfilled. What are they? Specific energy. When a fuel is heated, that should give maximum amount of energy, maximum amount of heat energy. That energy is called specific energy. The fuel should give high amount of heat energy. Such a fuel or such a fuel is called a good fuel. That is specific energy. Joule per kilogram, the unit. Next, calorific value. The amount of heat energy is released. Suppose amount of heat energy is released when 1 kilogram of fuel is burnt to produce lighter heat. Such value is called calorific value of the fuel. Its value is called calorific value. And when fuel is heated, that's give high amount of energy. That is called calorific value. So the calorific value is kilojoule per kilogram. The unit of calorific value kilojoule per kilogram. So different fuel has a different calorific value. For example, solid fuels have less calorific value. 1 kilogram of fuel is burnt, that produces energy. That amount of energy is calculated. Such amount is called its calorific value. Simply, solid fuels have less calorific value. For example, it is 17,000 to 22,000. 17,000 to 22,000. That is wood. We have burnt wood. The calorific value is 17,000 to 22,000. Then when we are taking some liquid fuels like diesel, petrol and kerosene, these three have the same calorific value, that is 45,000. 1 kilogram of fuel is heated, it gives kilojoule, 45 kilojoule per kilogram. 45,000, not 45,000 kilojoule heat energy is released for such a fuel. These are all liquid fuels. When we take gaseous fuels, for example hydrogen, this has 1,50,000 kilojoule. 1,50,000 kilojoule heat is released by hydrogen gas. That's why the gaseous fuels are good fuels. It is called as good fuels that has high calorific value. Understood? So gas has, especially the hydrogen gas has 1,50,000 kilojoule. So these are the different fuels and its calorific value. Next we go octane number. What is called octane number? This is a number which is given for the especially petrol fuels, petrol users, if you know. When octane number is higher, that fuel has ideal fuel. Octane number is higher. Petrol has higher octane number, so that considered as a ideal fuel. Cetane number, this is given for the diesel. This is for the diesel fuel. This has for the diesel, when the fuel has high cetane number, that fuel considered to be ideal fuel. Cetane number is higher value. Cetane number is higher value. That fuel considered to be ideal fuel. This is about the cetane number, octane number, calorific value, and the specific energy. These, by using all these values, just we can consider the efficiency of the fuel. Understood? Efficiency of the fuel. This is about efficiency. Next we go alternative fuel. Alternative fuel. Okay. To some extent, this diesel, petrol, kerosene, that everything going to be used up. Just we are using up. We cannot be reused. Understood? So these some extent, for example, next to 50 years or next to 55 years, the petrol diesel will be goes up. That means will not be get like today. That everything used. It is not renewable. It is not renewable resources. So for that, which one should be the alternative fuel? So for overcoming this problem, which are the fuels we should be using? We should be used in the future. No, we should take some of the measures for using that. For example, biodiesel. Biodiesel, that is good alternative fuel for the diesel. Biodiesel. Instead of using diesel, we can try to use the biodiesel, because that everything the biodiesel is produced by using of the plants, biological segments. So we should be modifying the production of engines, that is automobiles engine, should be on the basis of using biodiesel instead of using diesel. So this should be, the government should take care more about this. Biodiesel is a good alternative fuel. Next one is wind energy. Wind energy that we know by using of windmill, we are producing electrical energy. No, that energy is called wind energy. So that we should be use maximum. For the electrical, we should use maximum of wind energy. Even in Tamil Nadu, like Kayathar and Aravai only, so that some regions, some places, the wind energy is operated and it produces electrical energy by using of wind energy. So next alternative fuel is gobar gas. Gobar gas, that is also some extent it's selfless. Gobar gas you can use instead of using petroleum gas for domestic purpose, domestic cooking purpose. Instead of using LPG, we can try to use the gobar gas. Even we are using biodiesel, wind energy, gobar gas, only one fuel should be in the future good fuel, future alternative fuel. Actually, what is that fuel? No, hydrogen gas. Hydrogen gas. It is the definitely it should be the better future fuel. Why no? It produces less residue. When hydrogen is heated, hydrogen is combusted, that form water. That's all. No other carbon dioxide, some other residue, nitrogen dioxide, sulfur dioxide, and all. It forms only water. That will not any residue. It gives less residue. The hydrogen gas have high calorific value. That is the thing you should be keeping in your mind. High calorific value. So that which is the best. Next one is solar energy. That we should be considered for using alternative fuel. Solar energy. In a different manner we are using the solar energy for the different purpose. That also should be considered. So this is also one of the better what is alternative fuel. Yes, student. So far we have discussed petroleum and fuels. We should go through the lesson thoroughly. You can get a clear idea. Thank you.